Hey P-Stats, Mr. Zmudo here, lesson 1.11, and today we will be continuing with the chapter 5 notes. So go ahead and open up your chapter 5 notes. You can find those in Monday's agenda. The link will be the same. You should have completed this. We should have done this in class together. So this video will cover the second page of your chapter 5 notes. So take 30 seconds here to pull up chapter 5 notes on Canvas. Go ahead and split screen Canvas right now with this video so you can watch this video and take notes at the same time. And while you're doing that, go ahead and pause this video and read the context of this problem. So pause this video and read this and try to make sense of this data. Give you guys about 10 seconds there. So now that you've read the prompt for this question, we're going to be looking at this data, this summary data over here, real quick before we actually jump into the question. So we know that there's a group of students and they went on a trip and they're changing their dollars to euros. And in order to change dollars to euros, you need to take whatever dollar amount you're doing, that's your dollar amount, multiply it by 0.89, and then subtract 4 from it. And what that'll do is that'll convert it to euros. What we see over here are these summary statistics of the group of students, and we can see here is that the average student bought $277. This S right here is the standard deviation. So we have a standard deviation of about $90. That, to me, that seems a little bit spread out. So maybe we have some pretty high variation in terms of how much money each student bought. This is the lowest value. So someone only brought $110 on the trip. Maybe they think that that's enough. The first quartile, the median, Q3, and then someone brought a lot of money. They brought $535. To me, this seems like an outlier. We can calculate it and calculate that by looking at the fences, but we'll get to that if we need to. For now, it's important to understand that all this is in dollars. And what we want to do is we want to convert this to euros. Now remember, to convert to euros, the question told us that you need to multiply by 0.89 and then subtract 4. The 0.89 is the euros per dollar, and then the $4 is a service fee that they charge you. So question 1 says, what is the mean amount that students will receive back in euros? So the question is, how is mean affected by scaling, which is the multiplication, and by shifting? If you took notes in class today, here when we talked about shifting and rescaling data, you should know that means, the average, these are affected by both shifts and scales. So in other words, the average amount that a student bought in terms of dollars was $277.14 with 14 cents. To actually figure out how much the average is going to be in euros, well, we would just multiply this by 0.89. That covers the scales. And then to cover the shift, we're going to just subtract $4. 4 euros, sorry. And this will give us a value, I'm using my calculator here, about 242.65 euros. So again, I calculated the new mean by both multiplying it by my scale factor and shifting it by adding or subtracting a constant. In this case, I subtracted 4. Over here, what is the standard deviation amount that students will receive back in euros? So standard deviation, this is a measure of spread. And spread, we know, is only affected by scales, not by any shifts. So the original standard deviation was $89.35. I'm going to multiply this by 0.89 to get it in terms of euros. This gives us a value of about $79.52. So standard deviation is not affected by shifts. So I did not need to subtract $4 there. Median, similar to mean, is affected by both shifts and scales. So for the median, which we know the median for dollars was 210, multiply this by 0.89 and subtract by 4 because it's affected by both scales and shifts. Scales are when we're multiplying by a factor, shifts are when we're adding or subtracting a constant. Now the interquartile range, a little interesting, but what we could do is figure out what is the interquartile range in terms of dollars. So the IQR in terms of dollars, remember it's Q3 minus Q1. So let's say 325 minus 170. And that gives us a value of $155. So the interquartile range for dollars is 155, but we want that in terms of euros. So remember, interquartile range is a measurement of spread. So spread is only affected by scale. So I'm going to take this value of 155, multiply it by 0.89, and I'm not going to subtract 4 because measurements of spread are not affected by constants. They are not affected by shifts. So about 137.95 euros. All right, that covers that example. I know I went pretty quickly there, but again, this should be a review from today's notes. And mainly that when we're talking about shifting data, that means adding or subtracting some value. When you shift data, that affects measurements of position, like the mean, the median, Q1, Q3, the maximum, the minimum. When you talk about multiplying the entire data set, so like here we multiplied by 0.89, that affects everything. That affects the standard deviation, that affects the mean, that affects the minimum. So scaling is a lot easier because that affects everything. Shifting, you just have to remember, does not affect measurements of spread. So IQR and standard deviation. All right, and then the last question here. $535 seems to be a lot to bring on the trip. Would you consider $535 to be unusually high? Please use statistical reasoning to justify your answer. Show all work. So remember I said that this 535 seemed to be pretty high compared to the rest of this. And I said we could figure out if it's an outlier. And what I want you guys to know right now is this is actually going to be the first time you see something where we talk about unusually. And this is when we talk about the mean and the standard deviation. So in order for something to be unusually high or unusually low, it needs to be more than 2 standard deviations away from the mean. So what we know is that our mean was $277.14. And if I add 2 standard deviations to this, so 2 times the standard deviation, which was $89.35, I get a value of 455.84. So think of this as like an upper fence, similar to that of an outlier. If we have a value that's more than 2 standard deviations away from the mean, it is considered to be unusually high. So in this case, yes, it is unusually high. Since it's more than 2 standard deviations away from the mean.